All right, in this video, we're going to practice our magnetic force calculation skills. So here we have a magnet, and it's a pretty strong magnet. And so the North Pole is here on the top, the South Pole is here on the bottom. Remember, the magnetic field points from the north to the south. So in between these two poles, the magnetic field is pointing downward. Okay? So what I'm going to do is I have a loop of coil here, and it's probably got about 50 loops around it. So each loop will have a force. When I put it with the magnet and turn on a current, each loop will have a force, and 50 together is 50 times the force on just one loop. So I put a bunch of coils together here so that we can magnify the effect so it's easy to see. So what I'm going to do is, in this arrow shows me the direction that the current is running through the loop. So as the current passes this point here, it's going upward, but of course, as it's going here, it would be pointing the current would be pointing this way. As it's going here, the current would be pointing down. As it's going through here, the current would be pointing in that direction. Excuse me. All right, so what I'm going to do is place the coil inside the magnetic field. Now, I don't have any current in there. So with no current, that means the force is zero. I is zero. QV, or the current, cross B is zero, so there's no force. Okay? There's none until I start turning on the current. Okay? So let's calculate what direction the force will be on the coil. So if we use our right hand rule here, we let our pointer finger be QV, or the direction of the current, which when we go through think about this, when we go through the coil right there where the magnetic field lies between the two north and south poles, the current will be coming out towards you, okay? So the current's coming out, B points downward, so I'd have to point my hand like that, rotate my wrist, so my second finger there points downward in the direction of B from north to south, and my thumb will point in the direction of the force, so out towards me, okay? So to the right, to our right, both of our rights, okay? So here we go. Watch closely. It's a pretty strong effect because we've got 50 coils there. So when I flip the switch, there's our current. There's our force to the right. Bounced off the meter, the generator, current generator here, and got sucked back over to here because the force was so strong. Now, let's do this. What if I reverse the direction of the current? So this time, I'm going to put it in so at this point the current's moving downward. But of course, when it's going through where the magnetic field lies, in the middle here, it's going into what do we want to call it? Into our screen when it's going through the spot where the magnetic field is. Because remember, the magnetic field is zero up here, where the magnetic field is strong down here. Okay? So when I do that, let's predict what the direction of the force will be. Again, pointer finger is pointing now into the screen, and that's our pointer finger. The second finger will point in the direction of B, which is downward, okay, from the North Pole to the South Pole in this region right here. And so that means our thumb points in the direction of the force, which will be to the left. So if I put it all the way to the right here, we'll see it sucked over to the left. Ready? Indeed, that's the way it goes. So practice this at home, right? Try some different directions in your mind and see if you can get your right hand rule to operate properly. Like if I were to turn the south pole of the magnet upward, flip it over. Now we have the south up top. If I put my coil in like that, figure out which direction it would go. So here the magnetic field is pointing from the north to the south. That means the magnetic field, our second finger, will be pointing upward. The direction of the current as it's going through the middle there would be into the screen, your computer screen. So calculate B. So So do that for a second, pause the video, and then I'll come back on and we'll show you what happens. Ready? Here's what happens. We get the same force to the right, okay? So give this a try at home, see if you can calculate it properly, and then you'll know that you're using your right hand rule correctly. Remember, QV or IL with your first finger, second finger is the direction of B, and your thumb then is the direction of the force. All right, thanks.